Hello everyone, you are all welcome to another tutorial. This tutorial is designed in a hierarchical learning method. We start with very basic machine learning using logistic regression and decision tree algorithms. Next, we enhance our machine learning accuracy by doing some parameter optimization. After that, we enhance accuracy by adding the feature engineering to the machine learning mix. We use the data augmentation to enhance our accuracy to even little more higher. Finally, we learn save all of our work as a model to the disk and reload the model from the disk to perform another prediction using the test data set. So this example is an end-to-end machine learning example to build your machine learning pipeline. So let's get started. Here you can see the GitHub for this tutorial is open. All the Jupyter Notebook and the related datasets are already available in this folder. This folder is part of public code, public repo, which you could clone it and have access to all the Jupyter Notebooks and data. This tutorial starts with loan prediction starter Jupyter Notebook, where we perform the logistic regression and decision tree classification on this loan prediction data to perform the prediction and do the perform the end-to-end machine learning process. At last, we save this machine learning model and reuse that saved machine learning model to perform the prediction. In this second Jupyter Notebook, we enhance our learning by performing the feature engineering. Rest of the content is identical to the previous Jupyter Notebook. In this third Jupyter Notebook, we enhance what we have done at our second stage and we augment our source data with another set of data set which I have created to perform this data augmentation example. By combining the source data set and the augmented data set, we have seen that how we could improve our machine learning model performance, and that is part of this third Jupyter Notebook. Rest of the processing is quite identical. At the fourth and the last Jupyter Notebook, we are not performing any machine learning training. Instead, we use the saved machine learning model which we have saved in Jupyter Notebook number 1, or the very first part of this tutorial, and we use that model to perform the prediction on the test data set which we haven't used yet. So how you could load a test data set and modify it so that it's all that processing what you have done for your training data set. So you follow everything in this test data set, and finally you also perform the encoding. So the data set format is the exact same way as it was in the training for the model. Once we have achieved that stage with our test data set, we use this saved model and perform the prediction, and that is what we have covered in this fourth Jupyter Notebook. And the very first loan prediction starter notebook is open, and first we are going to import the pandas and numpy. As you could see here that I do have this loan test and loan train dataset available. So I will be reading loan train dataset, and that dataset will be stored in this object loan data. As you could see here that loan data frame is about 614 rows and 13 columns, and then the very last column is our loan status column which has true and false. So this data set will be processed as in our machine learning algorithm, and the result will be shown with either true or false or yes or no. So first thing, once we read our data, we need to understand how good our data is, the quality of data. And the way you could understand the quality of data is to understand how many empty or null values are. At this point, as you could see here, we are using this method to calculate all the null values in each individual column. Here you could see that gender, married, dependents, and various other columns, they do have several null values in those columns. So in order to perform the machine learning, we have to have the good quality data. So what we need is, in the next step is to fill these values with some of the information. And we will learn how to fill those values in those individual columns. As you could see here, loan data is our data frame. Count tells that total number of rows, and if total value is less than the total number of rows, then you can understand that the difference between these two values is the empty or null values. So that's one option you have. There is another way you could get the same information what we have got here, and whether you are asking for is NA or is null, the results are going to be same here. So first we are going to look each individual column and apply some of the logic to fill those null values. So we will walk through column by column all the way to the end. First we have gender. As you could see here, there are 489 male and 112 female. So if we want to fill the value, we have several options. One, the 13 empty value, one goes to male, one goes to female, all goes to male or all goes to female. However, a common practice is that you always look in your data frame what is the highest value, what type of the value is the highest, and use that to fill value. So here, because the male numbers are dominant, so all those empty values will be replaced by the male here. At this point, we are just checking here, and as you could see here, that gender does not show any empty value. It means data is updated here correctly. Similar to, we will walk through married. The married, 398 folks are married versus 213 is not married. So yes is a dominant value, and we will fill that here. Same thing with dependent. Here you could see that there are 345 folks who do not have any dependents in this data set. So we are going to fill that value here. Next, look into the self-employed. Self-employed are very few, but the most of the people are not self-employed, means they have employment at some place else. So we are going to use that dominant value here. And finally, we are looking into the loan amount. This here. So we have this loan amount, and as you could see here, that the minimum of loan value is 9, maximum of loan amount is 700. So the mean value for the loan amount is 146. So we are going to fill with mean value here, because this value is a range here. So this is the first value we saw in our data set, which has the range value. So we are going to fill all those empty values with the mean of loan amount. Next, we can look into the loan amount terms. There are 14 loan amount terms values empty. We can look into that what is the distribution here. As you could see here, that highest loan amount term is 5 years, 360 months, and the lowest is 12, means 1 month. So in order to fill, we can use the dominant value, and that's what we have done. Similar to credit history, we can see that credit history, they have 475 people versus the 89 folks they do not have. In case the 1 is the dominant value, so we have filled everything. So we walked through every column which had null values, and finally we can look into and see that our data set has shown here that there are no longer any null values. It means we are good, and we can at least start our machine learning process. There could be other ways people have did this whole empty value replacement differently, and there could be several ways it can be done. But the objective here is that at the last, before we start machine learning operation, at least we have a good data. We are just sampling here, random sampling of the data. We can look into 614 rows and 13 columns, and just the data look like this way. So very first thing, what we need at this point is that we need to split our data set in a way that we could take the status column, which is our prediction column, outside from this training data. So as you could see here that we have 13 columns here. So what we are trying to do is that we are taking from column 1 to 12 in one data frame, all the machine learning column, and the status column is here. If you see here, once we do this thing, the machine learning columns, if you see here, they start from male. So what we have done here is that we have started our index from 1. It means the 0 index, lone ID, is removed when we split this data frame. So lone ID is not selected as it. And it does not provide any value to ML process because every lone ID is unique here. So in that scenario, it does not really have any contribution to the machine learning process. So we have already removed here. So from column 1 to column 12, they all became part of this object, and the status column, if you see here, all the values which we saw in the status columns are stored here. So we have split our source data into two different data sets. One where the training information is available, and the second where the results related with these rows are also in different data set. Now using the Scikit-learn model selection method, we are going to split our training data into training and test data set. Here we are using the alg ML columns, where the machine learning training data columns, status column is here, and the test size we are using 1/3 or the 33%, and random state we are using here, as you could see here, 0. So we are loading this method train test split. In order to have this function, you must have Scikit-learn installed in your machine. Now we have got this xtrain, xtest. So we have got the training and test data for the training data set, and then train and test for the result data set. So if you are interested to know the shape of these, you will be able to see here that you see here 409, and if you look into here, the two of 5. So this should show you that 1/3 and 2/3 data is split between training and test data frames. Similar to here, they all using the exact same split. (409) because there is only one column, and then for Y test, perfect. Everything is same. So now at this point we have test and training data set available for us to start our machine learning process. And what we will do is that we are going to use the logistic regression method available within the Scikit-learn. Let's try to use it, start it, and you see. As soon as we started, we created the classifier object which uses the logistic regression. If you want to know what our classifier details are, you can always come and look into here. As you could see here, this is what logistic regression configuration look like these parameters are set whenever this classifier will be used to perform the fit operation on this training data, X-train and Y-train. Remember, this was our Y-train, so the values as well as our training data set. And here you could see very clearly that the V hit this error is they could not convert a string to float. At this point, as you see here, that scikit-learn logistic regression method is not able to understand these values directly. It means these are the string values, they have to be encoded in order to understood by the logistic regression method. So how you are going to do that? The scikit-learn already gives you the encoder. So what this label encoder is, that it does some really very simple thing. It's not nothing magical about it. It looks into each column and total number of unique values, and depending on total number of unique values, it just encode them as a 1, 2, 3 or 0, 1, depending on what the requirements are for that particular column. Same thing if there is yes, no, 0, 1, male, female, 0, 1. If there is a 3, 4, 5 values like this third column, then values will be 0, 1, 2, 3, 4. Here we have rural, urban, semi-urban, etc. So these values will be encoded. So very simple process label encoder does. So this function I have added intentionally so you know why we hit error, and then it also gives you information that why you need to perform the encoding. So now you could see here that these are the places where encoding is really needed. So 1, 2, 3, 4, 5, 6. So we have these 6 different columns which requires encoding here. So we are going to import this label encoder coming out from scikit-learn. We will instantiate this label encoder X, and for 0 to 5, so for I in range 0, you need all these 6 of these items, and we will perform. Here is the fit transform for train. And at this point, if you look into our X train, everything is encoded here. So 0, 1, 2, 3, depending on urban, semi, everything. So this encoder has taken care of all that encoding part needed for us to start the machine learning process here. So at this point, we will be able to perform the machine learning. Now we need to do exact same thing for our Y train, because there is a yes and no, Y and no at this point. So we are creating the label encoder Y object, same thing transforming, and now you could see here all those Y and N, they are transformed into 1 and 0. We have taken this values Y train 120th record similar to here just to show that those values are there as we could see earlier. Okay, so we have done for training data set encoding. Now we could do the test data set encoding. We have performed everything. Now the logistic regression we were trying to perform here, this logistic regression classifier, we are exactly doing the same thing. The only thing is that we have changed the classifier name just to make sure that we have different objects available. Here you could see that we have logistic regression classifier. We are not changing any settings for it. We are just using all the default settings here. And now we are giving this X test data set to it. And now we have Y prediction logistic regression. And here you could see that the results are available for us. So what we have done, we have used this training data, which has all the training values as well as their results fed into logistic regression classifier. It performed all those processing, and now that object can be used on the test data set, which is the X test data set, to perform the logistic regression result. And this was the results coming. So whether for each value, for each row, there is a result, whether it's yes or no. So now we need to understand that, okay, out of 205 values we have passed in this X test, what percent of these values are correct. So in order to check the correctness of this classifier, we need to perform the model accuracy, and that can be calculated based on accuracy score. And here you are going to see is that we are going to use this logistic regression, which is here. You could see this regression, and now we are going to pass the Y test, and Y test is the data frame which has all the correct values. So these are the predicted values, and this is the real and correct values. So we are going to import the metrics from Scikit-learn, and we are going to check the accuracy. So 82% accuracy means 4 out of 5 results are correct, and about 1 out of 5 results are incorrect when we have used the logistic regression. Using confusion matrix method available in Scikit-learn, we can actually develop the confusion matrix and based on our logistic regression. So here is your confusion matrix. If you combine all these totals, it will be total number of records you have in your test data set, because that is using this value here. So 205. So this total should be 205. If you 6 plus 2, 4 plus 3, 7. So 205. So true, false, and all those. I think it's better if you look into the confusion matrix details on internet and learn more about it. Now we are going to use another algorithm, which is the decision tree, also available in Scikit-learn, and we are going to perform the decision tree. We are going to build a new model using the decision tree classifier. This is our object, and then we are going to pass exact same our training data, and here we have passed it. Now same thing, we are providing the test data, and here are our results. In this scenario, we have got these results. Now we need to perform the accuracy. So Y prediction decision tree, make sure this is the classifier we had, and here is the Y test data. And here you could see that our prediction accuracy with this decision tree model is about 72%, which is lower than logistic regression. We could also build the confusion matrix for this one too, and here everything look like. So we have seen that in the logistic regression we had about 80% performance. With the decision tree we had 72%, and decision tree algorithm can be modified to improve its accuracy, similar to all other algorithms. So depending on how much experience you have and you have better understanding of the data, you could play these parameters and they could help you to improve your model performance. So here in this example, what we have done is that we have actually added one more parameter. It's called the max depth. It means that for this decision tree, when machine learning is performing the understanding of data, the total number of depth, how deep a tree could be created, and that is maximum 5. Do not cross more than that. So we have created a new improved classifier based on decision tree, and now we are using that classifier to perform the fit. And here you could see we have ran, and the only big difference is that max depth is 5 here, and if you look into these parameters, that will also be visible here, max depth. So you might have a question, okay, if now we are using the depth here, what was the depth when we ran the decision tree classifier previously? We could go back and look into here, and as you see here that the max depth we haven't decided in this one. It just used the default as none. Now this we going to predict again, and here you could see that just adding the depth value, we have got our decision tree accuracy almost 10% high, and it's almost equal to logistic regression. So that was a very quick example for you to see how very quickly you could use scikit-learn and the logistic regression and decision tree classification to perform the prediction, and not only perform, you also have a very quick test to improve its accuracy. Next, you might say, okay, how we are going to use these models which we have created to perform the prediction from a new new value which is coming. And the way it is, the answer is very simple. The simple answer is that for every row, you are going to take that row and present that row to these models in exact same way they have seen the data when it was given for the training. So here you could see that when we were training, the data was similar to here xtrain or xtest. So we can go look into how our data really look like. What I will do here, I will say, okay, let's look into the xtest. This is our data. If we try to say what does the xtest really look like, this is how the data look like. If we try to look 100th record, there is a record. So what you are seeing is that this is how the data was sent by the system when it was given for machine learning algorithm to be trained. Now we can look into the, we had y test 100, and here you could see that for in our test data set, for this row the correct value was 1, because our test data set already has the correct value built into. So if we would want to do a test, we could take this record and we could use that record here. Now we are going to use this sample data, and now if we look into this sample data at this point, this sample data is actually the this sample data is actually, here you could see that the type of sample data is a list. We are going to take this NumPy modules, and with the help of NumPy modules, we are going to convert this to in a format which is understood by the classifier. So here you could see we have performed, and now this sample data item, which has the exact same format as it can be understood by the classifier. And in order to look into that, you see here that xtest, it exactly look like in this format. And that's the reason we wanted this sample data which we have input to make sure it is in exact same format as is needed for the classifier to understood it. So we are using DT classifier with predict and passing this sample data item, which will have the predict result, and it has only one value. If we look into the very first value, and it's going to show that predict result is 1. So the value was 1 is correct. If we want to use the improved classifier, we can do exact same thing here. This, and this is the prediction here, as you could see here. And if we want to do 0th value, and result will be 0. So that's how, if we want to use same way to logistic regression, we could use this, get the this is our logistic regression. That was the value, sorry, we need to make this. Here is our logistic regression, and here you see so values are, this is our result. So you have seen how you could perform the prediction just by passing your 1 or 2, the number of rows you would want to pass here. If you want to pass more rows, you could just in this array just add 1, and then you can add 1 more array in case if you would want to. So after that, we have seen pretty much end-to-end machine learning process here. Next, we want to save this model to the disk. For that, we need this pickle module, which is easily available, and you just need to install in your machine where you would want to run this Jupyter Notebook. We have created this file name called the loan prediction model.bin, and we are going to save this file. And as you could see here, we have just at this point, this file is saved on my local disk. It means the loan prediction model.bin file has the model which we have just created very recently. If we want to store this model where we have improved machine learning, and we could use this parameter here, and that is going to save this one. So now we have the improved machine learning model, which has about 80% accuracy, means 4 out of 5 results possibly will be right. In the next step, we are going to read this model. So here you see file name is still the same. So we are using file name, and then this is the loaded loan prediction model. Model is here. If we want to see about model, we could see here, and very quickly you could see that it shows there is some max depth 5. So exact same model which was saved in this bin format, and bin is not really needed. You could call XYZ123, whatever you would want to name it. I just call it bin here. So exact same model is read from the disk, and now we are passing a sample data. Could be anything. You just need to make sure that data format is correct, and the order of column is exact same way the way it was while we were training the data. That's our sample data. We are using this loan prediction model here, and here are our results. So very quickly we have completed our loan prediction starter example from start to end. Now we are in the second phase of our tutorial. In this tutorial, we are extending the previous Jupyter Notebook and just enhancing the data set with the feature engineering. So most of the processing in this Jupyter Notebook is identical from the previous one. So I will try to run through most of the code very fast. The only place where we have added the feature engineering code, I will be putting more emphasis to it. So very first, we are importing Pandas and NumPy and loading the training data set, exact same training data set we have. All the empty values here. Next, we are filling all those values with appropriate data, and we have already seen this here. Done. And at this point, all our data is filled with, all the null values are filled with appropriate column specific data. Data is very good at this point. And now here comes the feature engineering. So we are going to use two different examples to learn feature engineering here. As you could see here, that we have two different columns. One is called the applicant income and second is co-applicant income. So we could combine these two columns and call them total income, and total income is basically for every row combination of applicant income and co-applicant income. So for every item in this loan data, create a new column called total column, and in that particular row complete the total column total income value with the loan data, applicant income plus co-applicant income. We have completed it. As you could see here, the number of rows are still same, but one new column is added. If we look into here, total income column is added here. So that's one very good example for us to modify the data in a way that we could make our input data much better, much more informative for machine learning process. As you could see here, the total income, more information about here, you could see that the maximum is 81,000, minimum is 1,400 total income, depending on total income value. Now what we need to do is that depending on this total income, we could bin these people who come in this min or max category. So binning is very important. It it put your input data in a way that very quickly you could understand the distribution of the rows depending on the number of bins you have in that particular column. So minimum value is 1442, maximum is 81,000. So we could decide how many bins we want. And as you could see here in this method, which is available in Pandas, it's called the Pandas pd.cut, and we are passing the total income column, and we are suggesting for this method to please use 20 bin. And once we have 20 bin, those values depending on the total income values will be put into one particular bin where that value fit in between min and max plus the total number of bins. So let's try to experiment this first. As you could see here that we have seen that this total income group, there are 1, 2. So if you would want to understand that how many total income groups are available, we could take this. We could say loan data total income groups. These are the value we have. If you want to get unique, as you could see here, these are the different total income groups depending on where they really fit. So these are the different groups available. And if we want to understand how this works, we could change this to 10 bins, for example. Let's do 10 bins. Now we look into here, you see that distribution is different. If we decide that we only need 5 bins, it will be different here. And depending on where the values are, you could see that binning is done here. One more very important parameter here is the labels. If I say labels are true, you are going to see here that its labels are true. Labels are none here, and after you made labels equals none, as you could see here, the instead of the label, it actually telling you that depending on this 5454 value, this value is in this particular bin range, and here the bin are 5. If we try to decide the bins are 20 and we use same method, now you would see little more granularity in your data. So now this 4941 fits in this bin. So you have very good understanding of where these rows are being fit into depending on where this total income fits in that binning category. So first thing, we need to have the bins which is like easily distributed across min and max. We have good understanding of that, how data distribution. And second, we need to have the labels equals true. So we will have those 0, 1, 2, 3 labels and coded values available instead of this range. Let's go back to here. We need to say labels are false. Labels false, unique value depending on bins 10, and now all those values are encoded value, numeric values. So we have performed feature engineering to generate the total income and then use the total income to bin the data set. Now the same loan data set which has 13 columns, now it has 15 columns because it 2 more columns are added, and the loan ID all the way to loan status was our original source column. Here is the list of columns as you could see here, and if you remember in previous example, we have split our data set in a way that all the columns, they were in one object or one data frame, and then the next only the yes no column where the prediction column or the dependent column was, that we have split it. So now if you look into this algorithm, we have the 14th column means the last one is the loan status, but loan status is here right now. So we have to adjust our data frame in a way that the columns are arranged properly. So what we will do, we will take this whole, we will try to put this thing correctly here. So this is our order of columns, and then the loan status, which is here, it has to come here. And after that, we have performed the shifting of columns, and now the loan status column is the very last one. So now what we are trying to do, we are taking from 1 to 14, means from gender to here in this data frame, and only the loan status in this data frame. And if you look into here, these are not data frame, these are the list of items. So now we have taken all the rows, convert them into a list of all the rows, and those rows will be used for us to perform the machine learning. So this second notebook was all about feature engineering. After that, everything is identical. So just for the sake of completeness, what I will do, I will just perform this training here. As you could see here, this will generate error because the encoding is not done. So we will perform the encoding here again. We have completed the encoding for training and test data. Now this is for test, and finally we are performing the logistic regression. And as you could see here, this is the result, and the accuracy is about 79%. Previously, when we started in this example, the accuracy for the logistic regression was 82%. However, after this feature engineering, we did not improve. Instead, we actually regress in terms of our accuracy. We can also look into the confusion matrix. That's here. Now we are going to do exact same decision tree, and let's see, accuracy is 70%, and here we have passed, it was 72. So we are going down with this feature engineering. Okay, now we are improving. Here we have max depth 5, the performance is 82 almost, and if you look into here, it was 80. Improved. So it was 80%, and after we have used is actually almost 82%. So finally we could say that the exercise we have done, it did work, but the results are visible only in decision tree algorithm or decision tree classifier used in this example. Rest is all same. Now if you want to perform the prediction, as you see here, this is the older code, so we need to look into the code which is correct. So X test is here. We need to take maybe 100th row, take this whole record, and we need to replace it correctly here. So now it's correct. Otherwise, the 2 columns were missing, and then that would have given error to us. And if I could actually use, I just wanted to show you, if we do not do, it's going to give error because the previous value was here, or this was the previous value. So let's try this way. I will try to use this sample data, and until then this is a array, next line will give error because it say the total number of feature is 13 and the input features is 11. It means the training was done on 11 features, but training was done on 13 features and you are sending only 11 features here, and that is wrong here. So for that reason, we have to take this and complete it with all 13 features as needed. Now sample data and result is. So that is our second exercise where we extended our loan prediction starter and enhanced our result using the feature engineering. And feature engineering could be done at very high level. This is just an example for you to get started. In the third segment of this tutorial, we are going to learn how to perform the data augmentation and perform the machine learning. What we are going to do is that we already have this loan training data set, and we are going to enhance this data set by adding another piece of information which we have added top of it. And let's try to learn that when we arrive at that point. So rest of the Jupyter Notebook is totally identical and very similar to these two other Jupyter Notebook, one for the starter and second starter with feature engineering. So let's start this. We have already imported this loan prediction training data set. Next, we are looking into the empty and null values. Then we are filling all those values correctly as needed. And finally, we have our good data set ready here. Just sampling our data set, and now here comes the data augmentation part. So as you could see here that we have loan IDs. For every row there is a unique loan ID. What if we have another data set where we know that every person in this row, which zip code they live, and for every zip code what is the living index? It means the income is really very high in that area, so index is there. So like depending on every zip code, the living index is also available. So let's try to load this data set first. So I do have this data set which I have just fabricated. Next, living index data frame, it's identical, 614 rows, and it has 3 columns. So we can look into that data set, sample it very quickly. As you could see here, it looks like this way, and we could do 10 rows, so you can get an idea. So these are the rank here. If you see here that total number of 614 loan ID, unique values for 614 unique loan ID, there is a zip code associated with that, and for the zip code we also have the rank. So now in order to do the data augmentation, we need to merge these two data sets together, and there could be many of these data sets available, and depending on project requirement, all that data has to be merged in a way that one single source of truth or the one single table is available which can be fed into the machine learning process. So the data augmentation, we are going to merge these two tables together and then use that final table as the source for our machine learning. So here we are performing the PD merge and taking the loan data, which is the source, and the living index data set, which is this new zip code based living rank data. So we have created this updated loan data object. As you could see here, that 2 columns are added, and they are added based on common property between the loan ID in loan data table and in the living index table. Once these columns are merged, 2 more columns are added in our data frame, and as you could see here, this is a 15 column, and our source data frame loan data still has a 13 column. So now we need to finalize our data set. So what we could do, even when we have these zip codes available in this new data set, zip code may not be going to add much more value if we want, or it is very much possible that another data scientist would think that, oh, they could use this zip code value and try to encode them in a way that and use them as a encoded 1 to 5 or whatever it could be values, because there are about 50 zip code distributed across 614 rows. So it can be used, but because these numbers are really very high, 50 of them, it's better to drop. So we are dropping this zip code in place drop, it means just remove from this data frame. Now there is only 14 columns and the zip code column is removed. And now we are just saving that zip code column back to loan data. And reason we are doing this so that we could keep using loan data variable in our whole example. Rest, everything is exactly the same here. As you could see here, now our data frame has the 14 columns, and then we are performing the feature engineering. After the feature engineering is done, we have to look into the columns, and you could see here that there are 16 columns in our source data set at this point, because 14 were first living rank, here is your loan status, and these 2 more columns here. So we need to readjust this part. Take this, replace back to here, and put this loan status back to here. Let me see. Oh, there is a one error. There you go. Columns are adjusted. Everything goes. Now you see here 1 to 15. So we have already dropped this loan ID in this, and then finally we have loan status. Everything, loan status column. Everything is going well. We will perform a logistic regression that will generate error. Encoding needs to be done. We have completed the encoding here. Reapplying, and here is the prediction. Here is the accuracy. Now you see that 77%. So we have achieved higher accuracy by adding the zip code related living index value. Now confusion matrix, if we try to use the decision tree algorithm, and the accuracy is 69%, even lower look like. Now we try to set the max depth 5, and if we try to here, see that our accuracy is about 81%. So this is the way we can enhance our machine learning process by augmenting that data from third-party resources, or they could be anything, as long as they are applicable for this project. Again, we just need to fix this value in a way that it is correct in order to perform the prediction. Once we are here, let's use 200 row, take this value, place it here, sample data and prediction. So that's all I wanted to show you in this third Jupyter Notebook, where you can extend your machine learning process by augmenting the data. Fourth and last part of this tutorial is to use the saved machine learning model and apply that model to the test data set, which is a brand new data set, and perform the prediction. So in the very first part of the loan prediction starter Jupyter Notebook, we have already saved our model. So in this example, we are going to use that model. So first, let's try to see what is our loan test data set look like. So as you could see here, we have loan train data set, and in last 3 examples, we have used this loan train data set. Now we are going to use the loan test data set. Here we are loading the loan test, and here you could see that this data set does not have the prediction column or the dependent column. So in order to make this data set ready for prediction, we have to perform the exact same thing what we have done to our training data set. So very first thing, we are going to look if there is any empty or null value. So we are checking empty or null values. If there are, we have definitely seen here, we are going to filling empty or values properly, and properly means depending on what is available in the column, and then we are using that. So I have done everything in a one single Jupyter Notebook cell, and as you could see here, everything is okay. Our data set is ready, and this is our data set. Now what we are trying to do is that we already have in this 12 column, so we are going to again take this data frame and convert into in a series which can be read by the machine learning process. So data frame is there, so we are taking the loan test 1 to 12 columns, and here, as you could see here, this is all that as our expectations are. Next, we are using the pickle modules, and that was our loan prediction model file name. If you are not sure, you could do ls l star.bin, and as you could see here, this is our loan prediction model file which we have saved. So we are opening, and that will be our loaded loan prediction model, and wherever applicable, I'm gonna name it correctly. Okay, model is load. If you want to see the model, as you could see here, this is our enhanced decision tree classifier model. And in this Jupyter Notebook, as you see, we are not doing any training. We already performed the training in past. We saved the model, and we are reusing the model to perform the prediction here. And at this point, what I'm trying to do is that I am trying to intentionally generate this error. And reason is that because our loan test data set is still in this form. Some of those string values are not encoded. Because of that, we are hitting this error. To solve this thing, we have to use the label encoder available in Scikit-learn. Now we are doing exact same operation, and at this point you could see that all our string values are removed from the test series and it's replaced with encoded values. Now we have a sample just to see how this data set look like, and here are the loan, and that's our result here. So we have used this test data set and performed the prediction method on this loan prediction model which we have created earlier, and that's all we really wanted to learn in this particular Jupyter Notebook. Let's have a quick recap. We started with Jupyter Notebook to perform the basic or starter machine learning process by using logistic regression and decision tree. We also improved the decision tree performance by changing few parameters. After that, we enhanced our learning by applying the feature engineering. And after that, we used the data augmentation techniques to merge source data with another third-party data and combining that data set to used as input for our machine learning process. And we learned how we could improve the machine learning performance. At last, we also learned how to save a machine learning model, how to reload the machine learning model, and modify your test data set in exact same way as it's needed in order to perform the prediction. That's all, my friends. I hope to see you in my next video. If you have enjoyed our content, please like it, share it, and subscribe it. At last, please be good and do good. Thank you.